Close your eyes for a moment. Imagine lying under a vast, open night sky, the kind you might see from a desert, far away from city lights. The air is cool, the earth is silent, and above you stretches a canvas painted with thousands of stars. Some glow faintly, like whispers in the dark, while others shine like watchful eyes, ancient and steady. In this stillness, the universe feels both intimate and infinite. A single shooting star might seem close enough to catch, yet your mind quietly reminds you even the nearest stars are so far that their light began its journey toward you long before your birth, long before humanity wrote history. This thought leads us to a question both simple and impossible. Can we truly comprehend the size of the universe? Welcome, dear wanderer, to the Wandering Neuron. Here, curiosity drifts slowly, like dust illuminated by moonlight, and questions guide us into the deepest corridors of thought. Tonight we step into one of the most mysterious puzzles, the unimaginable scale of the cosmos, and our human attempt to understand it. Long before telescopes, people stared at the heavens with naked eyes. Imagine a small group of ancient humans gathered around a fire, the crackle of wood filling the silence as they tilt their heads upward. What did they see? The sky was more than stars. It was a storybook, etched with myths and gods. The Babylonians charted constellations, believing them to be maps of divine will. The Egyptians built pyramids aligned with Orion's belt, as though trying to anchor themselves to the sky's vast design. For them, the question wasn't about numbers or measurements. It was about meaning. The immensity of the sky made them feel small, yet connected to something larger. Even without the language of light years or galaxies, they sensed the universe stretched into unreachable distance. And isn't that fascinating? Even with all our modern knowledge, that feeling hasn't changed. When we look up, we feel the same mixture of wonder and humility our ancestors felt thousands of years ago. In a way, the human journey to measure the cosmos is less about science and more about chasing that original spark of awe. Now, let us turn to the science, to what we know. Astronomers describe the observable universe as a sphere centered on Earth, stretching in all directions. Its estimated diameter? About 93 billion light years. But what does that mean? Let's slow it down. A single light year is the distance light travels in 1 year. Light moves at about 300,000 kilometers per second. Imagine circling Earth's equator 7.5 times in 1 second. That's light speed. Now imagine keeping that speed for an entire year. The distance covered in that time is 1 light year, roughly 9.46 trillion kilometers. To grasp that, if you tried to count to 9 trillion aloud, one number per second, it would take you almost 300,000 years. That's just 1 light year. The observable universe contains distances in the tens of billions of light years. And remember, light from the farthest galaxies we see began its journey over 13 billion years ago, when the universe itself was young. But here's the twist. While light has traveled for 13 billion years, the fabric of space has been stretching the whole time, expanding faster than the speed of light itself. That's why the universe we can see is not 13 billion light-years wide, but more than 90 billion. The expansion of space is like an inflating balloon. The galaxies aren't racing through space. Space itself is growing between them. This is our horizon of knowledge. Beyond it lies who knows what. Perhaps infinite galaxies. Perhaps nothingness. Perhaps regions forever hidden, unreachable, because the light from them will never have time to reach us. Here lies the deepest challenge. Our minds are not designed for such scales. Think about it. The brain evolved to deal with daily life. Distances across a valley. The size of a herd of animals. The length of a journey to the next river. Even the concept of a planet is already beyond the grasp of instinct. So when we try to imagine billions of light years, our neurons falter. Cognitive scientists suggest that our brains work with mental compression. When faced with magnitudes too vast, we create shortcuts. Instead of visualizing 93 billion light years, we say endless. Instead of picturing trillions of stars, we say uncountable. These words aren't numbers. They're emotions. And yet the very fact that we feel small proves something profound. Even if we cannot hold the entire universe in our thoughts, we can feel its weight emotionally. That feeling of awe, of insignificance, of mystery, is itself a kind of comprehension. In a way, the human mind is like a lantern in the dark. Its light cannot illuminate the entire forest, but wherever it shines, it brings meaning. Perhaps the universe is less about being understood and more about being felt.
Let us begin closer to home. Before we leap to the farthest reaches of space, we must first understand the Milky Way, our galactic island. When you look up at the night sky on a clear, dark night, you may see a faint, misty band stretching across the heavens. That is not a cloud. It is the glow of billions of stars packed together, blurred by distance, forming the shimmering backbone of our galaxy. The Milky Way contains perhaps 400 billion stars. Some are giants that burn with blue-white brilliance, living fast and dying young. Others are small red dwarfs, flickering quietly for trillions of years. Our own sun is but one among these billions, a modest star tucked into a spiral arm called the Orion Arm. And yet, this single galaxy is already beyond the grasp of imagination. The Milky Way stretches about 100,000 light-years across. Think of it. Light traveling at 300,000 kilometers per second would need 100,000 years just to cross from one side of our galaxy to the other, a journey no human ship will ever take. Even within this island, distances dwarf us. The nearest star beyond our sun, Proxima Centauri, is about 4.2 light-years away. To reach it with our fastest spacecraft, traveling at around 60,000 kilometers per hour, would take over 70,000 years. By then, humanity might have changed beyond recognition or vanished entirely. So before we even glance at the greater universe, we are already adrift in an ocean whose shorelines we cannot touch. The Milky Way itself is a universe within the universe. Humans understand by comparison. To imagine something vast, we place it next to something familiar. This is how astronomers teach us to think of cosmic distances, by climbing what they call the cosmic distance ladder. Picture this. Earth is about 12,742 kilometers across. If our planet were the size of a small marble in your hand, then the moon would be another marble about a step away. The sun, in this scale, would be a large beach ball about 2 city blocks away. Already the scale feels uncomfortable. But now, keep climbing. If the sun were a beach ball, then the nearest star beyond it would be another beach ball placed in Tokyo, while you stand holding the first one in New York. That is just our local neighborhood. And galaxies? If the Milky Way were the size of a dinner plate, then the next large galaxy, Andromeda, would be another plate placed about 2 feet away. Yet each plate holds hundreds of billions of stars. Now imagine all the galaxies, scattered like glowing plates across a table that stretches farther than the eye can see. And this is still only the observable universe. Beyond the edge of the table lies a space that may never end. The comparisons are dizzying. And perhaps that is the point. The cosmic ladder does not let us climb to comprehension, but reminds us just how far comprehension falls short. Yet still we try. Humanity, fragile and tiny, refuses to surrender its curiosity. We have built tools that stretch our vision outward, like extensions of the mind. The first step was parallax, observing how nearby stars shift against the background as Earth orbits the Sun. This gave us the first measurements of stellar distances. For the nearest stars, the shift is tiny, almost imperceptible, but enough for precise instruments to detect. Then came standard candles, stars like Cepheid variables that pulse in brightness with predictable rhythms. By studying the rhythm, we can know their true brightness, and by comparing with how dim they appear, we calculate how far away they must be. Further still, we rely on the redshift of galaxies. As space expands, light stretches. Galaxies farther from us have their light stretched more, shifting toward the red. By measuring this shift, astronomers map the deep structure of the cosmos, like cartographers of an invisible sea. And finally, there is the cosmic microwave background radiation, the faint afterglow of the Big Bang itself, whispering to us across 13.8 billion years. By studying its patterns, scientists glimpse the earliest seeds of galaxies, the primordial blueprint of everything we see today. These tools are like fragile ropes tied between mountaintops. They cannot pull the universe into our scale, but they give us pathways of understanding, small steps on the edge of the infinite.
No matter how powerful our telescopes become, no matter how advanced our equations grow, there is a horizon we cannot cross. It is called the cosmic light horizon, the boundary of what light has had time to reach us since the birth of the universe. Beyond it, galaxies may exist, or whole structures, clusters upon clusters, tangled in webs of dark matter, but we will never see them, because the speed of light, the very messenger of reality, has not had enough time to deliver their story. It is as though the universe has drawn a curtain, beyond which our eyes, our instruments, even our imaginations cannot pass. And here lies a question more unsettling. If we can never observe beyond that curtain, is it even part of our universe? Or is the universe defined only by what can be known? In philosophy, there is a saying, the map is not the territory. Our maps of the cosmos are not the cosmos itself. They are limited, incomplete, like sketches of a vast cathedral seen only by candlelight. Our perception, bound by biology, by physics, by time itself, cannot capture the full cathedral. But even so, the glimpse is enough to inspire awe. Perhaps the universe is not meant to be fully seen. Perhaps it is meant to remain partly hidden, so that wonder always survives in the gaps of our understanding. When we say the universe might be infinite, what do we mean? Infinity is not a number. It is not very big. Infinity is the absence of boundaries. If the universe is infinite, then every direction stretches forever. No edge, no border, no final star. Galaxies would continue without end, scattered like grains of sand across a shore with no horizon. But can the human mind grasp infinity? Mathematicians can describe it, play with it, even calculate with it. But to imagine it, to feel it, that is another matter. Infinity is a mirror that reflects our own limitations. Think of this. If the universe is infinite, then somewhere out there, the arrangement of atoms might repeat another Earth, another you, sitting in another room asking the same question about the universe, not once, but countless times. Philosophy trembles here. Are we unique, or are we one of infinite variations scattered across eternal repetition? Infinity dissolves the comfort of borders, of endings. And yet, infinity also comforts, for it means the universe will never run out of mystery. Now let us step into speculation, the edge where science touches poetry. Some cosmologists suggest that what we call the universe may be only one bubble in a vast foam of realities, the multiverse. In one theory, each universe forms like a bubble in boiling water, expanding and drifting apart. Some may be larger, some smaller, some with physical laws so different that stars never form or life never arises. Ours, by chance, is one where conditions allow for consciousness to emerge and to wonder. In another theory, quantum mechanics whispers of infinite branching. Every choice, every possibility may split into its own timeline, a new universe born with each turning of the page. In that vision, there are countless versions of you, some who made different decisions, some who never asked these questions at all. We do not know if the multiverse exists. It may forever remain beyond testable science. Yet the idea itself reflects something deep in the human spirit, our refusal to believe that reality is limited to what we see. Perhaps the universe is not a singular story, but an endless library. We, here on our fragile Earth, may be only one sentence in a book that never ends. When astronomers mapped the distribution of galaxies across the observable universe, they discovered something breathtaking. Galaxies are not scattered randomly like grains of sand in the wind. Instead, they are arranged in vast patterns, connected by invisible threads of matter. These threads form what scientists call the cosmic web. Imagine a spider's web stretched across billions of light years, with clusters of galaxies shining at the intersections. Between the threads lie enormous voids, expanses of almost perfect emptiness, so large they could swallow entire clusters of galaxies and still have room left over. When you see an image of the cosmic web, it looks uncannily familiar. It resembles the filaments of a human brain, or the intricate structure of neurons firing in thought. It is as though the universe itself is a mind, and galaxies are its ideas. Is this resemblance mere coincidence, or is there something deeper, a reflection of patterns that echo across scales, from the microscopic to the cosmic? We cannot say. But the image lingers, dreamlike, that perhaps when we look out into the universe, we are staring into a mind larger than our own. Yet even in this vast web of galaxies, we see only the faintest outline of reality. The stars, planets, and glowing nebulae that we admire are not the main ingredients of the cosmos. In fact, all the matter we can see, everything made of atoms, makes up less than 5% of the universe. The rest? Shadows and whispers. About 27% is something we call dark matter, invisible, intangible, yet holding galaxies together with its unseen gravity. Without it, stars would scatter like sparks in the wind. Though we cannot see dark matter, we know it must be there, silently binding the cosmic web. And the greatest mystery of all, dark energy. This invisible force makes up nearly 68% of the universe. It drives the expansion of space itself, pushing galaxies apart faster and faster, as if the universe is being stretched by invisible hands. We do not know what dark matter or dark energy truly are. They are placeholders for mysteries, names given to shadows. Some scientists compare our knowledge to standing at the edge of an ocean at night. We hear the waves, we feel the spray, but the water itself is hidden in the dark. The known universe is only a candle's glow. The hidden universe, vast, silent, and invisible, surrounds us like a sea of night.
If the universe is expanding, what happens in the end?
This question carries both scientific weight and philosophical silence. The answers are many and none are certain. One possibility is the Big Freeze. If dark energy continues to accelerate expansion, galaxies will drift farther apart until their light no longer reaches one another. Stars will burn out, leaving only cold embers. The universe will grow darker and colder until all that remains is silence. Another possibility is the Big Crunch. If gravity somehow overcomes expansion, the universe could collapse inward, galaxies rushing together, stars colliding, until everything falls back into a single point, a mirror of the beginning. Or perhaps the strangest possibility, the Big Rip. If dark energy grows stronger with time, it may tear galaxies apart, then stars, then planets, and finally the atoms themselves, unraveling the very fabric of reality. And yet, there's also hope in these endings, because each fate reminds us that the universe is not static, but alive, changing, evolving, like a story with many possible endings. We do not know which ending awaits. Perhaps, in some far-off multiverse, all endings happen at once. For now, we live in the middle chapters, in the warmth of starlight, in the brief time when galaxies still shine, and consciousness has risen to wonder at them. When we stand beneath the night sky, we feel our smallness. Earth itself is but a pale dot, orbiting a modest star, tucked away in the spiral arm of an average galaxy. Compared to the universe, we are smaller than a grain of dust, floating in a vast desert. Some feel despair in this thought. If the universe is so vast, they ask, then what are we? What does our brief existence matter in the grand scheme of things? But here is the quiet paradox. Even in our smallness, we carry the ability to wonder. A grain of dust that can think, imagine, and reflect on the infinite is no ordinary grain. In the words of Carl Sagan, we are a way for the cosmos to know itself. Perhaps meaning is not found in size or duration, but in awareness. A candle may not outshine the stars, but it still brings light to the room. There is an ancient idea that by studying the universe, we are also studying ourselves. After all, the atoms in our bodies were forged in stars that exploded billions of years ago. The calcium in your bones, the iron in your blood, the oxygen in your breath, all born from the furnaces of dying suns. This is more than poetry. It is science. When we say, we are stardust, we speak literal truth. You are made of the same elements that blaze in the heart of galaxies. And so when you gaze at the night sky, you are not merely looking outward. You are looking into a cosmic mirror. The universe is not something separate, cold and distant. It is within you. The stars are your ancestors, and the galaxies are your kin. Perhaps this is why the universe feels both alien and familiar, because in a deep sense it is both home and horizon. The greatest wonder is not that the universe is vast. The greatest wonder is that something so small as a human mind can contemplate it at all. Think about it. Neurons firing in your brain, tiny sparks of electricity are right now imagining galaxies trillions of kilometers away. The folds of your cortex are tracing the fabric of space-time. This is a miracle as strange as any cosmic phenomenon. Awareness is the paradox. We are fragile, temporary, destined to vanish. Yet in our brief window of existence, we can hold infinity in thought. The universe does not need us, and yet here we are, reflecting on it, naming it, wondering at it. In this paradox lies beauty. Perhaps the size of the universe does not diminish us. Perhaps it elevates us. For what is more profound, that the universe is vast, or that the vastness can be felt in the beating heart of a fragile being on a small planet? We often think of the universe in terms of space, distances, horizons, edges, but to comprehend its size, we must also think of time. time is the hidden dimension in which the universe unfolds. To gaze into the night sky is to look backward across it. When you see the light of a star, you are not seeing it as it is now, but as it was when that light began its journey. Some stars we see tonight may no longer exist. Their light lingers like a message sent long ago, still traveling across the cosmic sea. The farthest galaxies visible to our telescopes show us the universe as it was over 13 billion years ago. We cannot see them as they are today, only as they were when they were young. In this way, the night sky is not only space, it is a time machine. And yet, even this time machine has limits. Beyond 13.8 billion years, before the Big Bang, lies a silence we cannot pierce. Time itself may have begun there, like the shore of an ocean where no one can walk further. The size of the universe is not just its vastness in kilometers, but its depth in ages. To understand it is to float on an ocean where every ripple carries echoes of eternity. Eternity is not time without end. It is time outside of time. Physics hints at strange possibilities, that the universe may be infinite not only in space, but in duration. Some theories suggest a cyclic cosmos, expanding, collapsing, and reborn over and over, like the breath of an immortal being. Others suggest an eternal inflation, where new universes blossom endlessly from a quantum field, like bubbles rising in a pot that never cools. And yet, eternity is not easy to imagine. The human mind, bound to beginnings and endings, recoils. We imagine clocks ticking forever. We imagine calendars that never run out of pages. But eternity is not a line without end. It is the absence of lines altogether. Eternity is not time without end. It is time outside of time. Physics hints at strange possibilities, that the universe may be infinite not only in space, but in duration. Some theories suggest a cyclic cosmos, expanding, collapsing, and reborn, over and over, like the breath of an immortal being. Others suggest an eternal inflation, where new universes blossom endlessly from a quantum field, like bubbles rising in a pot that never cools. And yet eternity is not easy to imagine. The human mind, bound to beginnings and endings, recoils. We imagine clocks ticking forever. We imagine calendars that never run out of pages. But eternity is not a line without end. It is the absence of lines altogether. For poets, eternity is a sigh, a silence, a horizon that does not move. For scientists, it is an open question, written into equations they do not yet fully understand. For dreamers, it is the space where imagination continues after the story has ended. Perhaps eternity is not something to be solved, but something to be felt. A trembling in the chest when you stare into the infinite night. If the universe cannot be fully comprehended, if its size slips always beyond our grasp, what are we to do? Do we surrender? Do we stop asking? No. We wonder. Wonder is humanity's bridge to the infinite. It does not measure, it does not calculate, but it connects. When a child looks at the stars for the first time, when a philosopher writes of the eternal, when an astronomer spends nights searching the skies, all are acts of wonder. And wonder has no limit. It does not collapse under vastness, it expands with it. The larger the universe becomes, the deeper our wonder grows. Perhaps this is the answer to our question. We cannot fully comprehend the size of the universe. Our minds will always fall short. But through wonder, we can stand at the edge of infinity and feel its presence. And in that feeling, we are not small. We are vast because we carry the universe within us, in thought, in imagination, in awe. The wandering neuron drifts here, not with conclusions, but with questions that glow softly in the dark. The universe is beyond us, yet also within us. To wonder is enough. As we near the end of this journey, let us step back and notice the pattern. Human beings across time have always sought to understand the vastness of the sky.
first with myths, then with telescopes, now with equations stretching across blackboards. And yet every answer leads to another question, like circles expanding outward in a still pond. Perhaps comprehension itself is circular. We begin in wonder, we pass through knowledge, and we return again to wonder. The more we learn about galaxies, dark matter, and infinity, the more mysterious the universe becomes. It is as though the cosmos invites us not to solve it, but to walk with it, step by step, thought by thought, like a companion that always whispers something new. The size of the universe cannot be drawn to scale on paper, nor fully spoken in words. But it can be felt in these circles of discovery, spiraling outward without end. Here is a thought both humbling and astonishing. The brain you carry, only a kilogram of soft tissue, contains billions of neurons. These neurons fire in webs and clusters, forming patterns of thought that echo the cosmic web itself. Inside you, galaxies of neurons flicker. Synapses spark like stars. Memory drifts like comets across your inner sky. When you think of the universe, it is not only out there, it is mirrored within. You carry an inner cosmos, as mysterious and infinite in its depths as the galaxies above. Neuroscience has mapped parts of it, that the mind is still as full of shadows and unknowns as the outer universe. Perhaps that is why the stars move us so deeply, because when we look at them, we sense a reflection of something vast inside ourselves. We do not only inhabit the universe inhabits us. So, can we comprehend the size of the universe? In one sense, no. The numbers are too large, the scales too vast, the horizons too unreachable. Comprehension slips from our grasp like water from an open hand. And yet, in another sense, yes, we comprehend it not with numbers, but with wonder. We feel it in the silence of the night sky, in the awe that stirs when we imagine trillions of stars, in the trembling of thought when we consider infinity. That feeling is comprehension of a different kind, not of detail, but of depth. The size of the universe is not only measured in light years, it is measured in the space it opens within us, a space of humility, of reflection, of awe. And here we rest, in the mystery, not with answers, not with endings, but with a sense of vastness that keeps unfolding. The wandering continues, through stars, through thought, through the infinite sky above and the infinite sky within. Every measure of cosmic size begins with light. Light is our only messenger across the void, the thread that connects us to galaxies billions of light years away. But light is not only a measurement tool, it is also a language. When photons leave a star, they carry its story. A faint spectrum of colors reveals its age, its heat, even its elemental makeup. From across unfathomable gulfs of space, light speaks to us. It whispers, "I was born in fire. I crossed the darkness. I arrive now in your eyes." Imagine, the glow you see tonight might have been traveling since before humans existed, before Earth even knew the first breath of life. To comprehend the universe is to part learn the patience of light, to understand that distance and time are inseparable, and that all of space is stitched together by luminous threads. When we imagine the universe, we see stars, galaxies, radiant spirals, but most of the cosmos is darkness. Empty space, silent voids, stretches where not a single atom shines. But this darkness is not absence. It is presence in disguise. Within the shadows lie mysteries we have only begun to guess at. Dark matter, invisible scaffolding holding galaxies together, and dark energy, the unknown force driving expansion ever faster. To comprehend the universe's size, we must also comprehend its silences. The unlit, unseen, intangible vastness that surrounds the stars is part of its immensity. Perhaps more than the glowing galaxies, it is this darkness that defines the cosmos.
There is poetry here. The infinite is not always what shines. Sometimes it is the space between the lights that tells the truest story. Long ago, philosophers spoke of the music of the spheres, a belief that planets and stars moved with a hidden harmony. Science tells us their orbits are silent. Yet, in another way, they do sing. The universe hums with vibrations. The cosmic microwave background, a faint glow from the birth of time, can be translated into sound waves. A low, ancient hum, the after-echo of creation. Even black holes, once thought silent, produce ripples in space-time. Gravitational waves, like invisible notes ringing across the universe. To imagine the cosmos is to imagine a vast symphony. Stars flickering like violins, galaxies wheeling like choirs, space itself resonating with frequencies beyond human ears. If size overwhelms us, perhaps music helps. We cannot count every star, but we can feel their rhythm. The universe is not only vast, it is harmonious, a melody without end.
Every traveler meets horizons, a line where vision ends. The universe has its own, the cosmic horizon. Beyond it lies a distance so great that light, even after billions of years, has not reached us. Those regions remain forever hidden, not because they do not exist, but because their story has not yet arrived. Think of it. The observable universe is not the whole universe. It is merely the part we can see, a small circle of light in an ocean of darkness. Outside that circle, the cosmos stretches onward, possibly infinite, unreachable to any telescope, any future probe, any wandering mind. This is the ultimate horizon, not a barrier of walls, but of time itself. Beyond it, we can only imagine. The farther we look into space, the younger the universe appears. At the farthest edges of sight, we find not galaxies, but the afterglow of birth, the cosmic microwave background. This faint radiation is the echo of the Big Bang, still drifting through all of space. It is not bright, not dazzling. It is soft, almost hidden, a whisper that blankets the cosmos. To study it is to hold a fossil of time itself. Energy older than stars, older than galaxies, older than the heavy elements that make our bodies. When scientists listen to this radiation, they are not just measuring, they are eavesdropping on creation's first breath. Imagine, the size of the universe is not only in distances, but in memories, carried across billions of years, waiting to be heard. To gaze into infinity is to see mirrors. When we look far enough into the cosmos, we glimpse not only other worlds, but reflections of ourselves. Every star system suggests the possibility of life, of thought, of beings who may also look upward and wonder. Are they too asking if the universe can be comprehended? Do they dream, as we dream, of horizons they cannot cross? Even if we never meet them, the thought itself is a mirror, showing us that our questions are not small but universal. We are not isolated minds, but part of a greater pattern of curiosity written into the cosmos. The universe's size is measured not only in galaxies, but in the reflections it casts back at us. We see ourselves in its vastness, and in that recognition, the distance between stars seems smaller. In the end, perhaps the size of the universe is not something we are meant to fully measure, but something we are meant to marvel at. The farther we reach, the more the horizon recedes, reminding us that discovery is not about arriving at an end, but about expanding our sense of wonder. We may never grasp the full scale of the cosmos, yet in seeking to understand it, we uncover something just as vast within ourselves. Curiosity without boundary, imagination without limit, and a shared longing to know our place in the infinite. So when we look up at the night sky, we don't just see distance, we see possibility. And in that endless stretch of possibility, the question of how big is the universe becomes less about finding an answer and more about continuing the journey. In the end, the true size of the universe may forever remain beyond our full comprehension. Yet, in reaching for it, we uncover the beauty of curiosity itself. Every question we ask stretches the boundaries of our imagination,
And every glimpse into the cosmos reminds us how extraordinary it is to be part of this vast mystery. Thank you for joining me on this journey through the infinite. Until next time, keep wondering, keep questioning, and never stop looking up. Goodbye.